problem I was gonna put in on there, on Fourier transforms. I didn't, simply because I thought it would be too much, it'd take too long. I don't know if they go. All right. First problem was a convolution problem. You had two functions. The first function and the second function was h of t equal t times quantity u of t minus u of t minus 2. And I want you to find the convolution of those two signals. So you had to draw this one. This is taken from a homework problem. This is simply what that function is. The t of u of t minus t of u of t minus 2 simply is something that gates it. It's only on between 0 and 2. Then if you take a look at this, what I told you to do is find the one that has the most going on, and don't flip it, leave it alone for convolution. We could put the formal convolution integral here. We could say y of t is technically equal to the integral from minus infinity to infinity of, for that one I'll call it h of tau times vs of t minus tau, and then it's going to be d tau. That's the definition if we choose not to flip h of tau. Do you agree with me? It doesn't matter which one you put first, which one you put second. So I'm going to leave this one alone. And instead of t here, now I'm going to put tau. So it means this is just equal to tau right here, right? From 0 to 2 and 0 otherwise. Now we take the other function, or you go ahead and we flip and we shift. So when we do that, we get vs here of t minus tau. And this will be t, this will be t minus 2, with a height here of 1. And this is going to be for t greater than 0, less than 2. Now, does everybody agree with that, flip and shifting? Are we clear on that? Any questions about what I've done? This should be it should be automatic, almost right now. Now you can see the area of overlap. And this is one we talked about several times. I don't usually give one this easy for convolution, but I did here for a reason. If you were paying attention, this should have just checked that box and stopped your nerves. Right? This should have been going there. If you take a look at this one, it's this times this and then the integral of it, right? So it's really the area under this curve. Some people just took a look at that and they said it's really the base, which is t, right, times the height, which is t as well, correct? Divided by 2, or t squared over 2. So integrated tau, right, d tau. And you could say that in either case, here, the convolution, which I'm calling y of t, would be equal to the integral from 0 to t of tau d tau, or simply t squared over 2 for t greater than 0, less than 2. That would be the case. Is there any concern or any question about that? Now, next, we let this pulse move through. So now this is 2, 1, and now we're going to let the pulse move through here. And if this is t here, this will be t minus 2. The height of this will still be 1. Now we have our vs of t minus tau here, but now the area of overlap changes. Goes from what it was to this. And you can see it right there. Y'all agree with that class? How many remember doing this problem? Y'all should have. It was a straightforward problem. No tricks on this one whatsoever. So that means when I take a look at y of t here, it's going to be the integral of really tau d tau, same as the other one, but the limits change. Where do we go from? Where do we start, people?
T minus 2.
T minus 2, right? 2?
2.
2. Now some people here put the t. I mean, there were different problems that I could see, and it could have been a lot of reasons for it. But it was a straightforward problem. Now when you do this, you simply get tau squared over 2 from t minus 2 to 2. Some people left it just like this. They put 1/2. Then they put tau squared is going to be 4 minus, and they just put t minus 2 squared, and that's fine. That's the answer. You could keep on expanding it if you want. I mean, you all see that that could be 1/2, and then it could be 1 times 4 here, right? That's 4. There'd be minus t squared, correct? Minus t squared, then you get what? Minus 4t with a minus sign is plus 4t, correct? And then you get minus 2 times minus 2 or 4 with a minus sign. So the 4's go, and then you could put down 1/2 here, and it could be 4t minus t squared, or you could put down 2t minus t squared over 2. Didn't matter, any form like that. And that's going to be true now from 2, right, to 4. Correct, class? So this is true, this answer for t greater than 2, less than 4. And any form of those is correct. Everywhere else it's 0. For t greater than 4 or less than 0, the answer is 0. Are we clear on that, everyone? Now what does it look like? This is the shark fin, right? This is the classic shark fin. It does this. Well, sort of shark fin. Let me be careful about that. It's doing this. And this is 2 where it's its highest. This is 4, correct? This part is proportional to t squared over 2, right here. This is versus t. And this part really is proportional to that integration. And the peak height right there is what? F2 is what?
2.
2. And that's what it should look like. I gave you guys a lot of leeway with that graph. I saw some of the weirdest graphs I've ever seen in my life. I didn't cut you. I didn't hurt you on that one. But I did see a lot of shark fins, and I was glad to see that. Okay, that's the first one in a nutshell. Are there any questions? I want to thank you for recording this. It's helping people. I can tell you that just by the feedback. Now, I know a lot of people took off because of the storm. But Auburn's not going to close, I don't think, for anything. I mean, not this time. I don't think they need to. We're supposed to be 40-mile-an-hour winds tonight, about 3 in the morning.
I don't even think we're getting that now.
What?
I don't even know if we're getting that.
Well, I hope you don't get any, but 40-mile-an-hour winds can knock down trees. Sustained, especially with all this rain, you're going to see trees toppling. The next problem was this is Laplace transfer. I didn't have coffee straight out of them. I don't know if you realize that. I literally cut them right out of them. So the first one, I have 10 times e, this is 1, problem 2 part, I guess I had BAC, which is very strange. I don't know how that got labeled, but just call this 1. It's 10 e to the minus 4 times quantity t minus 2 times u of t, u of t minus 2, pardon me. And for that one, let me put them all down. The second one was equal to simply 3t times e to the minus 3t u of t. And the third one here was the second derivative with respect to t squared of e to the minus 2t u of t. And here I want the Laplace transform of these. right?
Yeah.
All right, for this one, I'm just gonna start by saying if I have 10 times e to the minus 4t times u of t, this will be without a time shift. Call this my x of t now for the problem. I know that that has the transform of simply 10 over s plus 4. That's almost by inspection. You don't need to evaluate that one. We've done it so often. Next, if that's x of t, now I can say if I have x of t minus 2, which is this, then I have simply going to have a shift, a phase shift, e to the minus 2s times 10 over s plus 4. That's the first one in a nutshell. Very quick. We've done it many, many times. Are we clear on that? Second one is, for this one, what I'm going to do is say, I have 3 times e to the minus 3t u of t here. I know that transforms is simply 3 over s plus 3, right? Straightforward? Now, anytime if I call this my x of t here, I know if I have t x of t, what happens over here? Class? Minus d ds, right, of x of s. Do we agree with that, everyone? When you do that, you end up getting 3 times s plus 3 squared with a minus, or minus that, which is simply equal to 3 over s plus 3 squared. Check that box. Are we clear on that, everyone? Last one. This one, you're going to get a little heartburn on, but I'm going to just show you how I think we should do it. I'm going to call for this one e to the minus 2t u of t my x of t, and that means that transforms to simply minus, that transforms as 1 over s plus 2. Do you all agree with that? This would be my x of s. Now, next I use the property second derivative with respect to t squared of x of t transforms as s squared x of s. You can get this by just doing the first derivative twice. Minus s times x of 0 minus x times x prime, x dot of 0 prime, right? And that property is something that we've covered. You could have got it with a single derivative property, right? And then did it again. You can do that. I don't know if anybody did that, but you could have got it several ways. Now, when you look at this, this is the thing I'm really looking for. That's the first part. And since this is my x of s there, I know that's going to be s squared, right, over s plus 2. Now, minus s times x of 0. Well, what is x of 0? Right? What is x of 0? This is my x of t, right? X of 0, when you evaluate it, at 0 is 1. Is it not, class? E to the 0 is 1. So it's just 1 there. Now, there's not an s on that one, pardon. I got an s there. Now it's just minus x dot of 0. Sorry about that. So when I do that, now I need a derivative of this. A derivative of this is 2 parts. It's going to be equal to minus 2 e to the minus 2t u of t. Then it's going to be plus e to the minus 2t times the derivative of u of t, which is delta t. And this is the one that's going to give you some heartburn. Because now you literally need to put that in there, evaluated at 0, which means this one is straightforward. That's minus 2, right? But this one, evaluated at 0, is 1 times a delta function. So I accepted a wide variety of answers here. If you had something that indicated you are doing a derivative the second time, you got full credit. And for this one, you literally replace that by simply minus 2 and then plus a delta function, delta of 0. And you could have left it like that, and that's fine. All right, I don't care how you left it. You know, I was really lenient about that. As long as you identify the problem. Because people didn't know, what's a delta function of 0? It's infinity. Oh, he wouldn't ask us that. It must be 1. Something in there is a trick. I didn't mean to make it that hard. You follow me in this class? Everything's straightforward on this test. You've had them. I can't tell you how many times we've done properties like that. Next. Next was a problem I took off my notes there. How many remember this problem on the board? Y'all remember it? Yeah. I just decided, make it straightforward. So you have a resistor here, goes into an op amp, or the inverting terminal, comes up here as a capacitor and a resistor, comes down here. This is V out, and this is V in. And that's the deal. Now, for this one, this was 4 ohms, right? This was 2, is that right? 1? Oh, I'm sorry, 1, and this is 2, right? So that means the impedance, I'm going to just put it in the S domain. The impedance of that is 1 over, what? 2S, right? Correct, class? Now, once you do that, we know we can call this right here Z2. So I can say my Z2 is equal to 1 over the first one, or 2S, plus 1 over the second one, or plus 1, or simply what? 1/2, right, times S plus 1/2. Do y'all agree with that? I'm just showing you, we did this several times. The next part, Z1 here, is just equal to 4. And I know my H of S, without going through, I mean, if you want me to, I'll go through the analysis, but we've been through this many, many times, haven't we, class? This is a standard operational amplifier in the S domain. Impedance between the negative terminal and output is Z2. Impedance between the input and the ground, or the negative terminal, is Z1, right? And it will be equal to minus Z2 over Z1, which is going to be minus 1/2, right? Divided by 1 over S plus 1/2, divided by 4. Or it's simply minus 1 over 8 times S plus 1/2. Does everybody agree with that? I'm going quick, but this should be obvious. Is it to everyone? Any questions at all? Now, did you have a question? Okay. Now next, I said my input V in of T was what? 2 times U of T, is that right? Is that it, class?
Yep.
All right, so that means when I go to the frequency domain, or the S domain, V in of S is simply equal to 2 over S. Agreed? Now my output is the input times the transfer function, H of S. So I can say my output, V out of S, is simply equal to H of S times V in of S, or it's equal to minus 1 over 8 S plus 1/2 times 2 over S, or it's minus 1/4 S plus 1/2 divided by S, correct? You all agree with me? All right, now I'm going to go ahead and expand that. If you expand that, you get A over S, these are simple poles, plus B over S plus 1/2. And to get A, I know to get A, I simply cover up the S, right? And I evaluate the remainder at S equals 0, correct, class? Y'all see at this one, it's going to be minus 1 over 4 times 1/2, or minus 1/2. Y'all see that, class? So that's minus 1/2 for A. For B, I know the pole occurs as S equals minus 1/2. Agreed? So now I come here and I cover up this, S plus 1/2, right? And then I evaluate everything at S equals minus 1/2, and you see the answer is 1/2. Do y'all see that, class? Please take a look at this. If you got this wrong, make sure you don't do it again. So this is 1/2. Now when we go to the time domain on this, right? That's frequency, or S domain to time. It's simple inverse transform pairs, and these are the ones you know so well. This is going to be minus 1/2 times U of T, correct? And this is going to be 1/2 times e to the minus t over 2 times U of T. And that's the answer. That's my output, Vs of T. That's it. In any form. Some people factored out the half. They did all sorts of stuff. But that's the essential. Clear on that one, class? By the way, what does this go to as t goes to infinity? Minus 1/2, right? As t goes to infinity, if you want to check it, the capacitor looks like an open circuit. So you should get what? The transfer function for this one would be what? Take a look. Minus 1/4, correct? If there's no capacitor, minus 1/4. The input is 2, right? Your output should be minus 1/4 times 2, or minus 1/2. And in fact, it is as t goes to infinity. Does everybody understand that? Last problem. By the way, how far up the coast, how far inland is that storm right now? Or isn't it? I thought I heard it made landfall. Is it still on the beach?
I think it might have made landfall, but I'm not sure.
It made landfall about noon,
At noon?
right around there.
So it's what, 14 miles an hour, it's just 14 miles inland. It's still going like that. It's still, I'm glad I'm not there. They always get these crazy weather reporters that must pay them $1 million to get out there. 90 mile an hour winds hanging on poles, debris flying all over. It's really bad. Have you thought that one through? I think that's rain. And it keeps repeating itself. Get another one down here, right? So that's the thing we're dealing with here. The triangles are repeating themselves. And then what I ask for, first thing I ask for, I think is C0, right? Average value. Well, the average value is what? First, let's just find this. When you look at the period, what's the period got to be? The time over which it repeats itself. From here, it repeats itself to there, 10, right? So t equals 10, just by inspection. So it's 10. After that, to get C0, the average value, I know it's going to be really the area under this curve divided by the period. So I can take the area under this curve, well, that's 2 times 3 times a half times 2, or really what, 6/10? Would be 6 would be the area over the period 10, or 3/5, right? And that would be the area. Correct, class? Very straightforward. Next thing we need is to get C of n, right? A general formula. I left you a lot of slack because I've seen some bizarre combinational stuff here. So we know we're going to get two derivatives, right? First derivative is going to give us square waves. Second derivative is going to give us impulse. We want impulse, right? And if you were foolish enough to do the integration by parts, then God help you, because that is a long one. So if I take the first derivative of this by inspection, and here's what I'm going to do. I'm going to limit myself from here to here. I want to go over the period that stretches through the origin. So I get a nice symmetric back set of values. When I do that, first derivative is going to be what? Height 3, range over which it goes 2. So that would have a height of 3/2, right? This is the derivative, x prime of t. Now from here to here, it's a negative slope, same magnitude. So then it goes down, and it's minus 3/2, ends at 2. This is minus 2. And that's my x prime of t. Does everybody agree with that? Class? Second, now we take another derivative. That's the square wave. We have to take one more, correct, class? Second derivative of that is going to be impulses. So now I got an impulse here at minus 2. The height of that is 3/2. I get another impulse, negative direction here, and that's going to be minus 3. And it's delta, this is 3/2 delta of t plus 2, minus 3 delta of t, and this one from, when I look at this, is another plus value here, and this is going to be 3/2 delta of t minus 2. Do we all agree with that? So now, I know this is a periodic series, and therefore it will render what? My Cn double prime for that is 1 over the period, the integral of x double prime of t times e to the j n omega naught t dt is minus there. And it will go from, say, minus t over 2 to t over 2, or from what? Minus 5 to 5, if you want. Minus 5 to 5, doesn't matter. When you take a look at that, really what we're doing is taking 1 over 10 here. Then we evaluate the x double prime, which is going to be, first one starts at t equals minus 2. It's got a weight of 3/2, right? It's got a weight of 3/2 here, and then it pops at t equals minus 2, so then it's e to the minus j n omega naught times minus 2 or plus. it's gonna be that. Then it's plus, and, minus 3. Minus 3. And that occurs to equal 0, so e to the j n omega naught times 0 is 1. Agreed? Finally, after that, I have another one, right? Identical in magnitude to the first. It's going to be plus 3/2, only will be e to the minus j n omega naught times 2. And that's Cn double prime. Now, if you did this out here and you got basically this over here, and you used it, you still got credit if you had basically only 3 of them. The 2 spikes that have a height of 3/2, the 2 delta functions, and the negative one that's got a height or a weight of minus 3. Follow me? So I gave you credit no matter how you did it on this. Now, what I'm going to do, you don't have to do this, but I'm going to do this. You all see this and this is a cosine. Look, e to the j n omega naught t, e to the minus j n omega naught t, added is 2 cosine of that argument. So I'm going to put it there. That means I have 1/10, right? Then I'll put 3/2 times 2 cosine of n omega naught times 2, right? And then it's going to be minus 3, correct? You'll notice the 2's here cancel, correct, class? Right? So I can get rid of that and that. And therefore I can say really what I have is really 3/10 times the quantity cosine of n omega naught t, or n omega naught times 2, pardon me, minus 1, and I can put in omega naught if I want to right now, but omega naught is simply 2 pi, right, over t, which is 10, or it's pi over 5, and I can put that in there, but it's not necessary for me to do that, understand? If you just identified omega naught and left it like that, it's still fine. But that's only c n a prime, double prime. To get the actual c of n, I have to divide this by j n omega naught squared, and that would be c of n. If you left it like that and identified omega naught, you got full credit. This is it right here. Or if you just took this and divided by j n omega naught, or this and divided by j n omega naught squared, this by j n omega naught squared, you got full credit. You understand? I didn't try to make this hard on you. I gave you a lot of slack. But that is it. Are we clear? And any form like that. Now, after that, usually what and I will do this on the final exam, I ask people to evaluate it for a certain value of n. And I choose one that's going to have a very clear answer, something easy. For instance, for this one, if I chose a value of n such that this argument would be 0, 2 pi, 4 pi, the cosine of that would be 1. 1 minus 1 is 0, the answer would be 0. Follow me? Or if I chose n such that this value would be 1, this value would be minus 1 and minus 1 is minus 2. Minus 2 times 3 is minus 6 tenths, would be another easy one. But the values of n I choose make the analysis easy. So when I ask for the answer, because some people get some really bizarre forms, I'll leave it up to you to evaluate. If your answer is right, you'll have the right answer next, hopefully. All right, last, I asked for the exponential Fourier series. I gave you full credit if you put the cosine series. I just want you to know. Somehow at that test, people they just defaulted to C0 plus the summation of 2 times magnitude of Cn cosine of n omega naught t plus the phase angle of Cn. I don't know why. It says exponential on my paper and every other paper I looked at, but that happens a lot. Now on yours it says exponential, right? If anybody says cosine series, bring it up here. I want to see it. So x of t is simply this. It's equal to the summation of n equals 0, or really minus infinity to infinity, not 1 to infinity, of, it's simply c of n e to the j n omega naught t. Now, if you identified c of n above, that's all you had to put. But most people put Cn in there again that they found before. That's it. That's all I wanted, to make sure you knew how to express it. What I didn't want, but you still got credit, was this. C0 plus the summation of n equals 1 to infinity of 2 times magnitude of C of n, where they put in the C of n, times cosine of n omega naught t plus the phase angle of C of n. Now, somebody, at least 2 people did it, and I don't know how come, and I was thinking, maybe I said something up there I didn't see. I don't think I said anything during the test that made you think that, but it was a gut instinct, a reflex. Now, we will be doing that one, but why is that one important? Anyone? What do these terms look like, people? Magnitude cosine of omega naught t plus phase angle. Something we can easily put in a phasor form, right? That's why we do that series. That's the whole reason. Understand, class? It's the same C of n as before, only now we use the magnitude up in front and we add the phase angle here. Got it? All right. Are there any other questions about the exam? All right, now, I know you want to run out of here. Me too. All right. I was going to go through DTS. If you want me to, I will. I'll be happy to do it right now. If you want to hang around, you're welcome to, and I'll be happy to do it or just talk with you about your test, whatever you want. I try to get through it without extending it very too long. Honestly, it was meant to be an easy test. I got 2 other people that have to take it. You know, the final average will get done. It was pretty clear we had a lot of really, really high grades and a lot of silly mistakes, minus signs. Some people. That's to be expected in the first test. Don't beat yourself up.